Everything is powered by batteries, including electric automobiles, drones, and laptops. Due to the fact that numerous businesses are developing battery powered electric aircraft, batteries have also taken to the skies. However, the existing lithium ion batteries have a number of drawbacks that limit their applicability in a variety of real world ways. Researchers have been putting a lot of effort into developing better batteries utilizing various materials. Graphene is one of these novel materials, but there hasn't been a major development. However, a team of scientists has created a new graphene battery that promises significant advancements. How does this group of scientists' graphene battery function? Join us as we explore the revolutionary new graphene battery that scientists have discovered. Batteries are a common feature of most electronic devices that may function without being plugged into a wall outlet. The battery's function is to store the energy used to power the apparatus. When the battery's charge level drops, the gadget is plugged into a power source, which could be another battery, to restore the charge level. Lithium-ion batteries are to blame for the continued use of electric vehicles. Prior to the development of lithium-ion batteries, the driving range and recharge times of EVs were severely constrained. Lithium-ion batteries, however, have made it possible for automobiles to have longer ranges and faster charging periods. This is not to argue that lithium-ion batteries are without flaws of their own. They're still heavy enough, though they offer improvements. Actually, they make electric vehicles heavier than those powered by internal combustion engines. Additionally, they continue to be expensive and take a long time to charge, driving up the price of EVs beyond what many people can afford. Additionally, because liquid or gel electrolytes can ignite and freeze, they require pricey warming, cooling, and safety monitoring. In addition, lithium metal spikes produced by quick charging may pierce the battery's porous separator, short-circuiting the cell. While solid-state batteries promise certain advancements, one drawback is that the cell physically extends as a result of lithium production on the anode, which must be taken into consideration in the pack design. They're extremely expensive to create, so several businesses are vying to be the first to sell them while trying to lower the price. Graphene-based batteries are one area of battery development that has recently attracted attention. Many issues with lithium-ion batteries will be resolved by this, which has been hailed as the next step in battery research. However, what precisely is graphene? Do you want to purchase a top-of-the-line Tesla flagship before that, though? Imagine owning a brand new Tesla Model X plaid supercar with a completely renovated interior. With a driving range of 313 miles, you can travel almost anywhere. With 1,020 horsepower supplied by the electric motors, you can reach a quarter mile in just 9.9 seconds. A layer of carbon atoms organized in a hexagonal lattice, 1 atom thick, is known as graphene. It is the component of graphite, which is what makes up the tip of a regular pencil. The term wonder material refers to graphene, a fantastic substance with a number of astounding qualities. The strongest and thinnest material known to man, graphene is only 1 atom thick. It is 200 times more powerful than steel. In addition, graphene has intriguing properties for absorbing light and is a superconductor of heat and electricity. Since graphene can be used in virtually every industry, it has the potential to revolutionize the world. It is possible to create a variety of materials with superior qualities by combining graphene with other components such as gases and metals. Researchers from all over the world are continually studying and patenting graphene to learn more about its unique features and its uses in things like transistors, computer chips, supercapacitors, and even DNA sequencing. Water filters, antennas, touchscreens for LCD or OLED displays, and solar cells can all benefit from the use of graphene. Scientists are constantly discovering new uses for graphene, which is really helpful. High-quality material production is still difficult, though. Numerous businesses across the world are now producing various types and grades of graphene materials, ranging from high-quality single-layer graphene synthesized using a CVD-based approach to large-scale production of graphene flakes from graphite. High-end graphene sheets are mostly employed in R&D projects or in extreme applications, such as sensors, while graphene flakes, which are produced in larger quantities and at cheaper costs, are used in a variety of products, including consumer electronics, sports equipment, automobiles, and more. But battery research and development is one of the hottest sectors right now. Graphene is of interest to battery manufacturers for a number of reasons, most notably for use in electric car applications. To enhance their batteries, they seek to make use of the material's high porosity, larger surface area, extraordinary strength, and low weight. These materials are useful for energy storage because they have high charging capacities, are flexible, and effectively conduct both thermal and electrical energy. Due to graphene's excellent electrical conductivity, which raises electrode density and speeds up the chemical reactions inside the battery, more power can be transferred and charge speeds are increased while producing less heat. Additionally, graphene performs better than lithium while undergoing less deterioration, thus extending the life of EV batteries. In addition, compared to other EV batteries, graphene batteries are more affordable and environmentally friendly. The implementation of graphene lithium-ion batteries is anticipated to happen the quickest among the many graphene-based battery technologies and types. By the next 4 to 8 years, solid-state graphene batteries may become a reality, and within 10 years, graphene supercapacitors. Lithium-ion batteries could possibly be replaced by graphene sodium-ion and graphene aluminum-ion batteries. Sodium and aluminum are more prevalent in nature than lithium, and they're also significantly cheaper and simpler to recycle. Future EVs may use graphene aluminum-ion batteries as their main power source because they can charge 60 times quicker than lithium-ion batteries and store a lot more energy than pure aluminum cells. For instance, AA batteries can be recharged in a minute and coin cell batteries in 10 seconds using graphene aluminum-ion cells. Nanotech Energy, a firm with headquarters in Los Angeles, is one of the businesses developing graphene battery technology. With a fireproof, graphene-based lithium-ion battery, Nanotech has finally discovered a solution to the safety issues with batteries. This is significant because it will completely alter the battery industry. The cathode and anode of a battery are made of graphene electrodes, which were created through nanotechnology. The flexibility of graphene allows it to tolerate the volume fluctuations that occur as the battery electrodes charge and discharge. This lowers the likelihood of an internal short circuit, which might result in a fire. Additionally, graphene is a superb electrical conductor, which aids the battery in maintaining reduced internal resistance. It allows that the battery made by Nanotech can sustain a lower internal temperature. Thus, it offers a successful remedy for overheating when charging, another potential fire cause. The electrolyte, an essential component that moves lithium ions between the two electrodes during charge and discharge, is what causes the fire risk in a traditional lithium-ion battery. It just so happens to be the explosive part. In the majority of electrolytes now in use, lithium salt is dissolved in a liquid that mostly contains carbonates with linear and cyclic chains. In essence, molecules containing a carbon atom join the 3 oxygen atoms. These substances are frequently flammable and, when subjected to high temperatures, may become volatile and unstable. In order to get around this issue, Nanotech created the stable, proprietary electrolyte solution known as organolyte. It is created from cheap components, is simple to produce, and is naturally inflammable. The ions must be able to transfer through the substance separating the electrodes of the graphene battery. Once more, Nanotech Energy has used a novel material to replace the conventional polyolefin separator that enhances the thermal stability of polyolefin. Additionally, this makes the battery safer. Naturally, you wouldn't expect Nanotech to divulge its trade secrets to the rest of the globe because doing so would help its rival. The name, however, suggests that the subject still revolves around organic chemistry. But according to a series of tests conducted by Nanotech, the graphene organolyte battery exhibits improved thermal stability and has no fire danger. The company performs a heating test at 180 degrees Celsius and a nail torture test in the brief video that was provided to media outlets. While the graphene battery is unaffected in both, the conventional lithium-ion battery utilized promptly catches fire. It's like witnessing the unimaginable take place. The graphene battery from Nanotech has been put to the test, and the results are remarkable. Extreme temperatures, from -20 to 60 degrees Celsius, have no effect on the battery's ability to function. However, it maintains its charge at temperatures of up to 176 degrees and won't ignite when pierced with a nail or heated to a temperature of more than 704 degrees. The battery from Nanotech is incredibly powerful, in addition to having exceptional fire resistance. It charges 18 times faster than anything currently available and keeps more than 80% of its claimed capacity after 1,400 cycles. Due to the graphene's high electrical conductivity, which reduces the battery's internal resistance, this is possible. The new batteries from the company can also be totally customized to match any form factor or container and are suitable for usage in consumer electronics, electric automobiles, and other electrified devices. The simplicity of the production of Nanotech's graphene battery is another benefit. The graphene battery from Nanotech can be produced using the same tools and procedures that are currently used to create lithium-ion pouch and cylinder batteries. They will be produced in a factory that will debut in Nevada in late 2022. Please share your thoughts about graphene batteries in the section below. Thank you for watching.